data.
Right.
And that data feeds into what Sarah and Marcus seem the most excited about in their notes, the behavioral matrix.
Oh, the behavioral matrix is amazing.
Yes, Sarah notes that it doesn't just give a flat percentage grade, which is huge.
Right, because a flat percentage score is really just a blunt instrument. I mean, it tells you the final outcome, but it tells you absolutely nothing about the cognitive journey required to reach that outcome.
So how does the matrix work?
Well, the behavioral matrix cross-references a student's test accuracy against their average reading and answering speed.
Okay, so it plots how fast they're moving against how accurate they are.
Exactly. And it sorts them into 4 distinct profiles: masters, rapid guessers, productive strugglers, and blind guessers.
The distinction between a blind guesser and a productive struggler is just profound.
It really is. Consider 2 students who both score a 40% on a reading comprehension quiz. In a traditional grade book, both of them simply receive a failing grade. The teacher has absolutely no idea why they failed.
The teacher doesn't know if the student finished the test in 2 minutes without reading a single word, or if they agonized over the passage for 45 minutes trying their absolute hardest and just couldn't process the archaic language.
Exactly. And those 2 students require entirely different interventions.
Because the student who guessed in 2 minutes has an engagement issue.
Right. And the student who labored for 45 minutes has a comprehension issue. The behavioral matrix basically makes this invisible effort visible.
It acts like an X-ray of user effort.
That's a great way to put it.
And Sarah even mentions that if a student's accuracy drops below 60%, the dashboard flashes a red needs attention badge.
But it goes way deeper than just flagging a poor grade. It identifies exactly which of the 6 core cognitive domains the student is actually failing in.
Because reading comprehension is not just one big monolith.
No, not at all. The system breaks it down into very specific neurological tasks. For example, a student might really excel at literal retrieval.
Meaning they can locate a specific fact that is explicitly stated in a paragraph.
Right. They can find the name, they can find the date, no problem.
Literal retrieval is essentially just a search function in the brain, right? You match a word in the quiz question to a word in the text.
Pretty much. But Marcus points out that history requires a completely different domain, which is sequence and cause, or inferential reasoning.
If we connect this to the bigger picture, inferential reasoning is neurologically much more demanding than literal retrieval, right?
Oh, absolutely. It requires the brain to hold 2 separate explicit facts in its working memory and synthesize a third completely unstated fact.
Which is hard. And history relies so heavily on understanding that, event A caused event B, which eventually led to event C. And knowing this changes the entire paradigm of intervention for a teacher.
It really does.
If a teacher knows a student has perfect fact retention, but completely lacks chronological timeline mapping, they don't waste time reteaching the names and dates.
Exactly. They teach the student how to actually map the connections between the events. It's like surgical precision.
Okay, but this brings me to a massive reality check.
Uh-oh. Lay it on me.
I really have to push back on the logistical feasibility of all this.
Okay, why is that?
Well, hearing about adaptive scaffolding, decoupled scoring, behavioral matrices, and real-time tracking of 6 cognitive domains, it sounds like a theoretical utopian dream.
Sure, it sounds like a lot of work.
Right. For a single teacher to build a dynamic, AI-monitored, multi-level text with pop-up synonyms and pronoun strings from scratch, that would take 40 hours a week. Teachers do not have that kind of time.
You're absolutely right. Implementation friction is the graveyard of educational technology.
Right. If a tool takes too long to configure, educators will just abandon it, regardless of how great its theoretical benefits are.
But the developers actually bypassed this bottleneck entirely by integrating what they call a frictionless ingestion engine.
And Sarah claims in the notes that a teacher can take literally any text, a primary historical document, a modern news article, even a dense textbook chapter. They just copy and paste it into the Creator tool, and the AI generates the entire tailored assessment in 10 seconds.
Yep, 10 seconds.
Okay, I am highly skeptical of that 10-second claim.
Why?
Well, we have all used AI chatbots, right? They hallucinate constantly.
Oh, sure.
If Marcus pastes a text about the American Revolution into an AI, how on earth does he know it isn't going to just hallucinate a completely fake historical event right in the middle of a reading quiz?
That is a very fair point. Your skepticism is entirely warranted when dealing with generative AI in an open-ended format.
Right, it's risky.
However, the AI within this ingestion engine actually operates under severe constraints. It is not generating new historical facts from the broader internet.
Yeah. Okay, so what is it doing?
It's functioning purely as a syntactic analyzer and a domain-specific question generator, and it is bounded entirely by the text provided.
So it's walled off from the rest of the internet.
Exactly.
It just looks at the pasted text, it maps those ambiguous pronouns, flags the high-level vocabulary for the pop-up synonyms, and writes the 30-question assessment based only on the words in that specific document.
Right. It acts as an analytical overlay rather than a creative generator.
Wow, there's a huge distinction.
It is. It builds the reading missions and the pre-reading launch pads, instantly, completely removing that barrier to entry for the educator.
That makes Marcus's reaction in the source document completely understandable now.
Right. He realizes he can pull a dense primary source document on a Sunday night, paste it into the engine, and have a fully active, dynamically scaffolded reading lesson built out.
Without spending 6 hours writing literal and inferential questions from scratch.
Exactly. The technology essentially leverages AI to handle the rote mechanical labor of scaffolding.
Which frees up the human educator to actually focus on the behavioral matrix and the targeted interventions.
Yes. It's using AI to build the safety net so the reader can safely learn to climb the ropes themselves.
We started this deep dive talking about the psychology of reading and that universally frustrating feeling of just zoning out while staring at a page.
And we've seen how the interactive reading coach doesn't just test comprehension after the fact.
Right, it actively engineers comprehension during the process.
It really transforms reading from this passive intake of information into an active, heavily structured mission.
It breaks those bad habits of skimming right at the starting line. It manages the reader's cognitive load, and it uses that stepladder framework to gently push them toward full autonomy.
All while protecting the integrity of the diagnostic data for the teacher and giving us that behavioral x-ray of effort versus speed.
So what does this all mean for you? We've explored how this psychology completely transforms a middle school history lesson. But I want to leave you with a final provocative thought to mull over.
Because the implications of this really do extend far beyond a 7th grade classroom.
They really do. The core problem of cognitive overload applies to all complex reading.
Absolutely.
Think about your own daily life. If this technology can dynamically scaffold 18th century primary source documents for a 12-year-old, just imagine what it could do for the really dense materials you have to process as an adult.
Oh man, it would be life-changing.
What if every 50-page legal contract you had to sign came with a pronoun trap anchor engine, so you never lost track of who the undersigned actually was?
Or what if the complicated financial reports or dense medical journals you try to decipher came with an adaptive scaffold that knew exactly when you were losing the thread of the argument and just gently nudged you to slow down?
Will the future of adult reading be just as interactive? I mean, we might eventually look back at static, unhelpful text on a screen the exact same way we currently look back at typewriters.
It really makes you wonder how much more we could all comprehend if the text was actively working with our brains instead of just sitting there waiting to be skimmed.
It certainly does. Thank you so much for joining us on this deep dive. Keep questioning, keep exploring, and we'll see you next time.